Okay, in this video, we're going to go over the first part of 2.5. So your day 1 assignment was to go ahead and handle these 4 problems. So on the next page, I'm going to go over the answers for those. But you're basically doing the same thing we've done in the past. And I said for these problems, just take the first derivative, set it to 0, find the critical value, and answer the question. Okay, so that's the key. You've got to answer the question. So let me go to the next page and we'll look at my work. Okay, you should check your problems with my work. So I said take the first derivative. Okay, that's going to be right here. Here's my first derivative. And you can see that I set it equal to 0 and I solve for x. And x was 20. Now I'm going to figure out what that is. Is that going to be a max or a min? So I did the first derivative test on either side, and I found the slope changes from positive to negative, and therefore it's a max. So then I also checked it with the second derivative, but I did not write a statement for that. Okay, so second derivative, what I'm noticing is the second derivative is everywhere negative. If the second derivative is everywhere negative, then your function only has one concavity, and that is concave down. So we can say at CV of 20, the second derivative is always going to be less than 0. Therefore, it's concave down, which yields a max. Now, what is the question? For what x does the function have its maximum value? Okay, so we're going to take the x that we have, which is 20, and plug it back into the original equation. Okay, so let me just continue. So the first question only asks for what x does the function have its maximum value. So the x that I want to identify is 20. So that is my answer. Let's go to the next one. So the next one asks for the maximum value of the function. So here's your function, 12x minus x squared. I take the first derivative, I check the x, at x is 6, I have a max, but I'm not done. So the next thing I want to do is figure out the f of 6. And that's going to be 12 times 6 minus 36. So I'm going to grab my handy calculator. I'm going to say 12 times 6 minus the 36. And I'm getting a value of 36. So therefore, my f of 6 is 36. And that is my answer. That's the maximum value. Okay, so make sure that you recognize that this is the answer because they're not asking for just the x, they want the y value, whereas in the first situation, they just wanted the x. Okay, let's go on to the third one. Find the minimum value. Okay, so take your first derivative. You can see what I'm doing. I find that this t will give me a minimum value, but that's not the minimum value. So what is the minimum value? So take your t. We're going to figure out the f of t. So let me just grab my calculator to figure that out. Okay, so when we read the problem, it's telling you to find 2 things. It says find the minimum value of the function and give the value of t where this minimum occurs. So here is where the minimum occurs, and when you plug the t in for 12, so let me just erase this really quickly. Okay, when I plug my 12 in here, I get 904, and you need both answers. So this answer and this answer. Okay, so number 4. For what t does the function have its minimum value? Okay, they only want the t. So I did all my tests. I wrote only the first derivative test out, but the t in question is going to be 12. Okay, so you should check your 4 answers here. You should have easily gotten these. All right, let's look at the next piece, and I'm going to have you work on this in class. So let me go to the next page, and let me grab the picture so that you can see what it is we're working on. Okay, so we're working on 5 through 10. Okay, so look at this first one. Find the maximum of q equals x squared. So they want to find the maximum of q if x plus y equals 2. Okay, so let's do that on the next page. So let me write this out. So this is 5. And you want to say, okay, q equals x times y. You want to find the maximum of it. And then they tell you that x plus y equals 2. Okay, the first thing you've got to do is rewrite q in terms of only one variable. So why don't I switch out the y? Y is going to be 2 minus x. So look what q is. X times 2 minus x. Until you have it in one variable, you cannot maximize this, okay? So now what I'm going to do is, instead of doing the product rule, I'm going to go ahead and first distribute that. Now take your derivative. Q prime equals 2 minus 2x. Set that derivative equal to 0. 2 equals 2x. That only happens if x equals 1. So x equals 1 is my critical value. Okay, so we're going to test this to make sure it's going to give us a maximum. All right, so do your sign chart. I put my 1 right here. I'm going to test to the left and to the right. So what if I plugged in a 0? What would my slope be? So I'm going to check my slope over here. My slope with a 0 is going to be 2 minus 0, which is going to be 2, which is a positive. Okay, what if I put in a number greater than 1? What if I put in a 2? That's going to make this 2 minus 2 times 2, which is 4, which is going to be a negative. So that means that the x I found, that x of 1, gives me a max. Okay, so I can say at the critical value of 1, the slope changes from positive to negative, which yields a max. Why don't we go ahead and do a second derivative test? So up here I'll do my second derivative. That's going to equal negative 2. So no matter what I put in for my x, it doesn't matter. It's always going to be negative, which is going to affirm because it's concave down. So at CV of 1, the f prime prime of 1 is less than 0, which leads to concave down, which leads to a max. Okay, so we have both statements. Now, they want the maximum value of q. We have not gotten that yet. So first off, I have to figure out, okay, so far, I know that x is 1. If x is 1, what is y? Well, y equals 2 minus x. So y equals 2 minus 1. So that means that y is 1 also. Okay, well, that's very good. We still have not come to our answer. Since I know that the x maximizes my quantity, and if x is 1, y is 1, what is the quantity at its maximum? Quantity is going to be 1 times 1, which equals 1. That is the answer they're looking for. You cannot get there directly. Okay, so what you're going to do is 6, 7, 8, and 9. Those are the ones I think you can handle. The whole thing is you cannot take a derivative if you have more than one variable. So that means your first step for 5, 6, 7, 8, and 9 was to figure out what is my new and improved function, and we're going to call this the new and improved function. It's in one variable, and then go ahead and solve it. I want you to attempt 10. 10 is very challenging because you've got 3 variables, and you need to get it down to being one variable. I think you can do it, but I'm more certain that you can do 6, 7, 8, and 9. So if I were you, I would go ahead and do 5 again, without necessarily looking at my work. Look back on it, see if you got it all correct. And then with that confidence, go ahead and do the other ones. If you had problems with 1, 2, 3, and 4, you have time to go back over that. Okay, so for the homework, I want you to post 5 through 9, even though I've already done 5. I want to see your work for 5, 6, 7, 8, 9, and then I want to see a really good attempt for 10, and that will be it.